Today we're looking at science, and I wanted to go into the nitty-gritty of some of the vocabulary, because I think when you look at vocabulary books and you look at the science and technology section, there's not really a great deal of science vocabulary in those sections. A lot of it is just idioms about science and technology, like the computer's on the blink. And that's okay, it's good that you know that idiom, but it's not going to help you if you start to talk about something scientific. I don't know, like something in the field of physics or in the field of chemistry. And I haven't actually done biology as well, although that's obviously the third science. And it's partly because I don't like biology, and partly because I'm not very good at biology, but I like these two sciences. And in particular, I like chemistry. It's my favourite science. I think that chemists are more scientific than physicists or biologists, and that's because I think chemists very often have a direct experience of the experiment. Yeah, physicists will often be using telescopes, or astrophysicists will be using telescopes to look at things that are light years away. Yeah, and remember the speed of light, we say light years for very, very distant objects. And so I think that in the other sciences, they're very often further removed from the actual experiment. You know that in a lot of physics now, it uses computer models, which really separates you from the actual experiment. There is no experiment then. And so for me, chemistry is the best. You have the substance right in front of you, and you change variables and you see how it behaves, and you find out what properties it has. But let's talk about physics first of all. And of course, with science, we're talking about the laws of nature. That's what we say about all of the gravitational laws and the laws that scientists have discovered in terms of springs or gases. We would call all of these the laws of nature. Yeah, the laws of thermodynamics are certainly part of the laws of nature. And the laws of motion, the laws of thermodynamics, are of course those laws that Isaac Newton discovered many years ago. And sometimes this is called classical mechanics. Classical mechanics means Newtonian mechanics, mechanics based on Newton, rather than the more up-to-date Einstein version. Yeah, that kind of thing. You get relativistic mechanics. And so you also get quantum mechanics, which isn't really Einstein, but it's certainly not classical mechanics. It's a different form of mechanics. So these are different disciplines, really, classical mechanics and quantum mechanics. And remember, we say physicist, and it's physicist, yeah, physicist, yeah, so it's physicist, physicist. Stress on the physicist. Chemist and biologist for that one as well. And physicists study magnetic fields, electric fields, electromagnetic fields, and gravitational fields. They're the main fields that any physicist deals with. And we can talk about atomic physics, nuclear physics. Now, of course, we talk about atomic bombs and nuclear bombs, and we talk about atomic energy and nuclear energy as well. So these are very important adjectives. You can talk about the fundamental laws of physics. Fundamental works very well with laws, yeah? Fundamental laws of physics. And of course, in physics, we have many constants, yeah? Many different constants. One of them is the gravitational constant. One of them is the speed of light, which is supposed to be constant, yeah? One of them is Planck's constant, which is a unit of length. And one of them is the electric constant. And so we have different constants in science. And these are values that never change. Or we assume, anyway, never change. Or we have discovered, it seems to us, that they never change. Okay, and so we have the theory of relativity. This is Einstein's theory. It involves space and time bending or curving. I'm not going to lie, I don't understand it. It sounds like rubbish to me. It sounds totally illogical. I can't help but think it's wrong. I really can't.